We're the QuadRover autonomous navigation team. My name is Greyson Kirkley. I was in charge of doing the GUI system for the user to actually be able to give the areas and the missions for the rover to actually traverse.
My name is Polickoski. I was in charge of the LiDAR system, specifically with the obstacle avoidance and landmark honing algorithms.
My name is Coit. I built the state machine that the navigation system runs on.
My name is Rivero. I made the calculations as well as the GPS adjustments for the navigation system.
The general goal for us is to be able to take this legacy rover and be able to add autonomous navigation capabilities, which with our actual addition of the LiDAR and being able to actually in the Pi and be able to actually go through courses and be able to traverse them without intervention by any user.
For the LiDAR systems on the rover, we utilize the LiDAR up here. It's the SF45 from Lightware. And I can process all its data through a Raspberry Pi 4B that was already on the rover. And we also have this nice LoRa low power radio module. And combining all these, what I did was, from the LiDAR data, I intook the any obstacles or any distance data that comes within 6 meters of the rover within a set border range around the rover. It's both the width plus a little bit more on the sides to confirm if an obstacle will actually collide. And from these angles, I'm able to intake them and put them through my obstacle avoidance and landmark honing algorithms that were programmed on the Raspberry Pi, and thus output a serial communication signal from the Raspberry Pi to the Arduino Mega to run the motor controls. And lastly, to send the GPS points of the landmarks that we're going to be using per each mission, we will be sending from Greyson's GUI the GPS points that will be received through the LoRa radio module and then serially communicated to the Arduino Mega.
So the core of the rover is a state machine based on a switch case, with each case having the various functions of the rover, and this allows us to transition between them. It starts out in case 0, where it loads all the waypoints in and it initializes its, it takes the first GPS point, and after that it moves into case 1, where it'll drive forward to get a second point from which it can compare the first point and the second point to figure out where it is and what direction it's facing. Once it knows where it is and where it's facing, it can turn to the heading it needs to go. Then once that's done, it can drive on that heading. And then as it drives, it'll check its location. And if the location is within the tolerance we've set, it'll load the next waypoint and then go all the way back to case 2, and the cycle will repeat until it hits the last waypoint.
For our navigation software, we have to utilize a calibration point to assess where we are, as we have to actively assign our local grid with the global grid, which is assigned based off north. To do so, we take a calibration point, we measure our angle to north, and calculate our angle to the waypoint with the angle to north, so that we can subtract these values in order to get our actual angle that we must turn guiding to the next waypoint.
So, to support the actual rover's mission, I went and created this GUI software to essentially be able to create our mission areas and to create the actual missions. The order that we go through to create them is that you create the area first. And what you do simply is just you input a valid GPS coordinate, and I'm getting these GPS coordinates from Google Maps because of the sense that it's so widely used, and then you choose a zoom level for your actual zoom in the sense of from Google Maps. And tile size is for how large you want the area to be, and that's how Google actually counts its areas, doing them in tiles. And for the area name, I'm going to create for video for the sake of this. You have to wait a second for it actually for the APIs, because I'm using 2 of them, Google Maps and Google Earth, to actually create this area. And all right, we got to finish. Then we're going to create our mission. We're going to load that folder that we had just gotten. It's going to be in our, there it is. All right. And then see, we got an area that's been selected. We're going to go and add our landmarks. So we're going to say we're trying to get to these separate points. You're like, all right, that's where I want to go. At that point, you create your config. Oh, I didn't make the mission name. And at that point, now you create the config. This is what's going to be loaded into the actual rover, and that's what we're going to do now. Is you're going to go into missions. You're going to select your mission file that you just created, which will have the name you give it. You open it. And at this point, you can see where you actually had them loaded and selected. And now you're going to connect to the LoRa to be able to send the config file over to the rover for it to actually be able to perform its mission.